Good day, everybody, from wherever you're joining us across the world. My name is Bart Baesens, and today I would like to talk to you about analytics in a big data world. First, I would like to start by briefly introducing myself. So I studied at the Catholic University of Leuven in Belgium. Leuven is the city where I'm based right now. It's a sunny morning right here in Leuven. It's 10 a.m. in the morning. It's very close to Brussels, and it's well known for a couple of things. First of all, it has the best university of the country, which is very good because that happens to be the place where I work. But besides that, Leuven is obviously also known for having good beers. In fact, we have plenty of good beers in Belgium, and one of them is being brewed in Leuven, right? It's called Stella Artois. It's a very popular beer. I wouldn't say it's the best Belgian beer because actually we export it quite a lot, but besides that, we also have other excellent beers like Trappist beers, etc. So I studied at the Catholic University of Leuven. I finished my master's degree there in 1998. It was, the program was called Business Engineer in Management Informatics. After that, I continued with a PhD at the same university, which I finished in 2003. The title of my PhD was Developing Intelligent Systems for Credit Scoring Using Machine Learning Techniques. If you would like to have a copy of my PhD, you can send me an email. I'm more than happy to share it with you. I'll be very pleased that finally someone wants to read it. Currently, I am a professor in Big Data and Analytics at the KU Leuven in Belgium, and I'm also a lecturer at the School of Management at the University of Southampton. My research is analytics, and I have a research team of about 10 PhD students all working on analytics. Some of them work on developing new algorithms, new ways of analyzing data based upon neural networks, based upon support vector machines, survival analysis, or social networks, whereas other ones work more application-oriented. They focus on application areas like credit risk analytics, marketing analytics, fraud analytics, and so on. In today's talk, the purpose is to give you an overview of some of our most recent research findings on the topic of big data and analytics. It will not be a very theoretical talk. It will be very practitioner focused because all of our research is conducted in close collaboration with companies. In fact, we have many companies worldwide that sponsor our research given the relevance of the topic in today's business world. If you'd like to stay in touch with the research we're doing, please feel free to connect on YouTube, Facebook, Twitter, or LinkedIn. In fact, if you go to my YouTube channel, Data Mining Apps, you will find some free movies discussing applications of analytics in a wide variety of settings. You can also visit my website, dataminingapps.com, where you will see our research nicely summarized with some key publications, free movies, etc. If you have some questions at the end of this talk, you can send me an email at the email address indicated at the bottom of the slide. I'm also more than happy to share the slides of this talk for free, so let me know if you'd be interested in that as well. Okay, so what's the overview of today's webinar? First, we're going to set the stage. We're going to look at the various ways according to which data is gathered by companies nowadays. Then we'll zoom into the analytics process model. We kind of give a bird's eye overview of the various steps involved as you set up an analytics project. Then we're going to discuss the analytic model requirements. If you want to build a good analytical model, what are the various requirements that you should satisfy? Obviously, this will highly depend upon the application, and we'll also discuss a few key applications there. We will also discuss some new emerging application areas like social network analytics. And when I say social network analytics, I'm not referring to LinkedIn, Facebook, or Twitter, but I'm referring to a network of nodes, entities, which are connected in a specific way. Think about customers calling each other. Think about firms being connected by means of the resources they share, etc. We'll also talk about business process analytics and HR human resource analytics, where we've been doing quite a bit of work on lately. And obviously, as with any good talk, I will finish with some conclusions. I will also give you a very brief demo of an e-learning course which I have been developing on the topic of analytics, but that we will come back to at the end of the course. First, let's talk about data. Well, no doubt we're living in a data-flooded world. If you look at the ways according to which customers interact with a firm, you can see that customers will interact across a diversity of channels, each time leaving behind a data trail. Think about the online channel. Customers can log on to your website and can visit web pages, can even put some feedback online, or maybe even place an order online. All of this information is stored electronically into web logs, for example. Customers can also interact with your firm by means of email. They can ask you for price quotes or maybe even file complaints. Alternatively, also call centers or customer service centers can be used to get into contact with a firm. Next, we have survey data. Think about online surveys. Think about all those websites these days asking whether the website experience was useful, yes or no, or whether a particular web page was interesting, yes or no. Also think about corporate data. Corporate data stored into transaction databases, whereby for every transaction, the timing of the transaction, the location of the transaction, the items that make up the transaction are stored. Think about data from partnering organizations. In a credit risk setting, think about credit bureaus. Think about companies like Equifax, Experian, TransUnion. Think about companies like Dun & Bradstreet and so on. So you can see this generates a massive amount of data in which you're going to have various interesting customer insights available. The only thing is that we need to get the customer insights out of the data by means of analytics. Using analytics, we can first study the data and then extract new patterns about interesting customer behavior. Here you can see the analytics process model from a bird's eye perspective. What is really very important as you start setting up your analytical exercise is to first identify the business problem. What is the business problem that you would like to solve using analytics? That could be fraud. That could be credit card fraud, for example, or it could be insurance fraud. Fraud is a very hot topic these days in analytics, and we're actually doing quite a lot of research on fraud as well, as I will refer to as we move through the talk. Could also be churn. Maybe you want to identify churners and you want to see what customers are likely to leave your company or what customers are likely to decrease the product or service usage in the future. Or maybe you are more interested in the holistic perspective and you want to model customer lifetime value, CLV. Or maybe you just want to segment your customers to understand the different needs of your customers. Once you have identified the business problem, you can start identifying the data sources. Those could be socio-demographic data sources, that could be online data sources, that could be information about your marketing strategies, marketing campaigns that you have been running, etc. The more data you can identify here as potentially relevant, the better, right? Based upon identifying all these data sources, you can then select the most appropriate, the most relevant data. Obviously, this data will be contaminated with all kinds of noise. Think about customers whose age is recorded as 300 years. Think about customers whose income is missing. Think about duplicate information, etc. All of that needs to be cleaned up during a cleaning phase. The cleaning phase can then be followed by a transformation phase. In a transformation step, you're going to transform the data, and basically this refers to enriching the data. For example, in a marketing setting, you could derive elements such as the RFM elements. RFM stands for recency, frequency, and monetary variables. Recency says how long has it been since the customer has made a transaction. Frequency says how frequently is the customer going to make transactions. Monetary says what's the minimum, maximum, average, or most recent value in terms of money of a transaction. So these are the RFM variables, and there are well-known examples of features which are being derived based upon the source data. Deriving those features is something that you will typically do during a transformation step. Once you've finished the transformation step, you are ready to start analyzing the data during an analytics step. Here, you will build either a predictive analytical model, which will predict the churners from the non-churners, which will predict the fraudsters from the non-fraudsters, or which might even predict the CLV, customer lifetime value. Or if you're not interested in predictive analytics, you may be interested in descriptive analytics. And the aim of descriptive analytics is to describe patterns in data, to look at association rules like what items are frequently purchased together, or to look at sequence rules like what are popular sequences of web page visits on my website. Or maybe you're just interested in some clustering. This is what you're going to do during the analytics step. Once you have finished the analytics step, the result will be an analytical model. You can then start interpreting this analytical model. You can start verifying and validating it, and then start deploying it and bring it into production. For example, if it would be a marketing analytical model, you can set up marketing campaigns with it, and then afterwards monitor the success of those campaigns. So as you can see at the bottom of my slide here, you can roughly distinguish 3 steps in the analytics process model. You have the pre-processing step, which starts from identifying the business problem to transforming the data. You have the analytics step, and you have the post-processing step. Obviously, the pre-processing step is the most time-consuming. Common estimates say that it takes up to 80% of the total analytics modeling effort. If you ask me, it's also the most difficult step. Here you can see some examples of popular applications these days. Fraud detection. These days, I have many companies asking me to teach courses on fraud or to set up some joint fraud research programs. We are currently doing active research on fraud in insurance, for insurance fraud detection, fraud with a credit card company, and we also have social security fraud that we're working on. Market basket analysis, whereby you're going to analyze market baskets using descriptive analytics to see what items are frequently purchased together. We also do a lot of work on social network analytics. We use social network analytics to detect fraud, and I'm going to talk about that later on in this talk. Churn prediction. Churn prediction means that you're going to predict what customers are likely to leave your firm in the next 2, 3, or maybe 6 months. Response modeling means that you're going to look at what customers are most likely to respond to a marketing campaign. And the response could be clicking on a link, or could actually be asking for more information, or could actually be making an actual purchase. Other popular applications are customer segmentation, CLV, customer lifetime value modeling, and web analytics. Here you can see an example of analytics to make it a little bit more concrete. This is an example in a marketing setting. So at the top of my slide, you see a data set. Obviously, it's a very small data set. It has only 5 customers, and each of those 5 customers has been described in terms of characteristics. The characteristics are the age, the recency, the frequency, and the monetary. Remember, recency refers to how long has it been since the customer made a purchase. Frequency refers to how frequently is the customer making purchases, and monetary, let's say, refers to the average amount of the purchase. RFM are very popular variables for churn prediction, for response modeling, and for customer segmentation. But what is typical here is that we have a churn prediction example. That means that we have a churn indicator. So the final column in this table indicates whether the customer has churned, yes or no, whether they actually stopped buying products or services with your company. The data set above has been nicely pre-processed. What you're then going to do is you're going to put it into some software. Think about SaaS, Enterprise Miner, or it could be any other types of commercial software, and you're going to build an analytical model. At the bottom of my slide, you see an example of a very popular analytical model. It's a decision tree. Have a look. If age is less than 40, yes, and frequency is less than 5, yes, then the customer is labeled as a churner. So this is an example of an analytical model that you can build from the data set above. It's a decision tree, and it has been used quite regularly in the industry for credit risk modeling, for fraud detection, and for churn prediction. This is an example of predictive analytics because you are predicting the customers as churners or no churners. In other words, you have a target variable available here. Decision trees are often referred to as white box models because they give a clear explanation into why customers churn or do not churn. Another example is in risk management. I started developing my first research and consulting practice in risk management. More than ever before, analytical models steer strategic decisions of financial institutions such as banks and insurance companies. If you look at models like credit risk models, for example, every bank in the world is obliged to develop models that quantify credit risk in terms of the PD, the probability of default, LGD, which stands for loss given default, and EAD, which stands for exposure at default. Analytical models are being built to predict PD, LGD, and EAD. The PD, LGD, and EAD are then used to quantify both the expected and unexpected loss which a bank will face in the next 1 year. The expected and unexpected loss are then used to calculate both the provisions and the capital buffers that banks should hold in order to protect themselves against those losses. And remember, we want to make sure that banks are well capitalized, because if banks are not well capitalized, they will run into problems, and it will also jeopardize our savings money. So we better make sure that the analytical models are well developed, because any error in the analytical models will directly translate to the PD, LGD, EAD estimates. From there onwards, it will translate to the expected loss and unexpected loss calculations, and it will then further cascade into capital provisions, etc. That's why worldwide international guidelines such as the Basel I, Basel II, Basel III, and Solvency II Accords have been introduced to come up with very specific regulation about how to appropriately develop PD, LGD, and EAD models, right? In essence, the Basel Capital Accords and the Solvency Accords are analytical accords. They are analytical accords in the sense that they carefully define the analytical inputs to the models, but also the outputs like PD, LGD, and EAD, and how these should be optimally combined. If you ask me, where do you see the most sophisticated analytical models in the industry nowadays, I would have to say in credit risk modeling, because there the importance is the biggest, right? Any model error directly translates into capital calculation errors and actually could also have an important effect on the macroeconomy as a whole. Think about the credit crisis which we have witnessed lately. If you look at the team members that make up an analytical team, all the various job profiles that will be involved in setting up an analytical project, you will see that you have the database or data warehouse administrator, because he or she is responsible for managing all the data. He or she can give us access to all the source data, but also to the data definitions. And remember, data is the key ingredient of any analytical model. But besides those people, we also need the business expert. The business expert is the marketeer, the credit risk analyst, the fraud analyst, the online marketeer, etc. And those people can give us very useful starting insights to guide our analytical modeling exercise. Not only to guide our analytical modeling exercise, but also to validate and interpret our analytical findings at the end of the analytical exercise. The legal expert is also very important. If we set up collaborations with firms, we always have a legal expert who can tell us to what extent privacy is respected, yes or no. Privacy is getting very important these days because you see a lot of data is being gathered, so it's very important that privacy can always be safeguarded. And then we have the data scientist, data miner, or quantitative analyst, the person who will be responsible for building the analytical models. And obviously, we have the software and tool vendors as well. So you see, a multidisciplinary team needs to be set up. Me and my team were being flooded by requests from all over the world to collaborate on data science related problems. And a question I often get is, what is the perfect profile of a data scientist? And this is my view on it. According to me, a data scientist should first have a solid knowledge about statistics, data mining, machine learning, however you want to refer to it. This refers to the quantitative skills. But next to a good quantitative background, a data scientist should also be good at programming, right? He or she should be good at programming in SAS, in R, or Java, because every analytical project requires tailored processing for which programming skills are needed. Also, communication and visualization are important, because the data scientist will make the bridge between the business and the IT, right? So you need to make that gap between, let's say, analytics and the business, and one way of successfully bridging that gap is by using appropriate communication and visualization facilities. Obviously, a data scientist should also be capable to perfectly embed him or herself into a business setting, and that requires business understanding, business knowledge. Data science is also a field with lots of new evolutions. So the data scientist should be properly aware of all the new developments and be creative and see how those new developments can add new business value. Data is the key ingredient to any analytical exercise. We already mentioned that, and it's very important that the data is of good quality because of the GIGO principle. Garbage in, garbage out. Messy data gives messy models. Me and my team, we have been doing industry projects in churn prediction, fraud detection, response modeling, and credit risk modeling. Throughout all of these projects, we have found that simple analytical models consistently perform well. And if I say simple analytical models, I'm referring to regression-based models like linear regression, logistic regression, and decision trees. Often we find that neural networks and support vector machines are powerful, but the added performance benefit compared to those simple models is really very marginal, even sometimes not existing. Hence, the best investment that you can make in order to boost the performance of your analytical models is not that much in those techniques, but in the data. Improving, enriching data is the best investment you can make to further boost the performance of your analytical models. So data quality is very important, and when I say data quality, I'm referring to data accuracy, I'm referring to data completeness, data bias and sampling, data definition, data recency, and latency. Obviously, the importance of those various dimensions depends on the setting that you're working in, right? But it is very important. In our research, we came up with a whole framework of different types of data quality criteria. And we nicely grouped them into access-related dimensions, representation-based dimensions, contextual dimensions, and intrinsic dimensions. I'm not going to go through all of them, but if you would go to my website, dataminingapps.com, you will find some more information there. So the key message I want to convey here is that data quality is very important in order to improve the performance of your analytical models. Analytics is a term which is often used interchangeably with data science, data mining, knowledge discovery, and so on. And what it refers to is it refers to extracting useful business patterns and or mathematical decision models from a nicely preprocessed data set. Roughly speaking, you can make a distinction between predictive analytics and descriptive analytics. Predictive analytics means that you have a target measure of interest. It means that you want to predict a dependent variable. And a dependent variable can be categorical. Think about a churn indicator, right? Churn, yes or no. Think about a fraud indicator, fraud, yes or no. Or it could also be continuous. Think about CLV, customer lifetime value. Or in a credit risk modeling setting, think about LGD, loss given default. In predictive analytics, You always want to predict the future based on patterns learned from past data. In descriptive analytics, you want to describe patterns in data. You want to cluster observations. You want to cluster customers. You want to cluster transactions. Or you want to detect association rules. You want to look at what items are frequently purchased together, because that helps you outlining your cross-selling campaigns. Or you want to find sequence rules. You want to find sequences of product purchases, or you would like to find sequences of web page visits. If you want to build a good analytical model, what are the key requirements of good analytical models? Well, first of all, there's business relevance. The analytical model should solve your business problem. If you want to detect fraud, then the analytical model should detect fraud. If you want to predict churn, then the analytical model should predict churn. That's pretty obvious. The next one is statistical performance. Obviously, the patterns that you find from the data, the segmentation models, the sequences, or the predictive models should have statistical accuracy. And there exist various ways of quantifying the statistical accuracy of an analytical model. You can actually do a PhD on the topic. I have one PhD student currently working on profit-driven evaluation of analytical models, for example. But statistical performance is only one part of the picture. When I did my PhD, I especially focused on statistical performance. But as I started working with companies, I quickly found out that other performance criteria are important as well, such as interpretability and justifiability. If I build credit risk models, I cannot use neural networks. Why not? Because credit risk models are subject to supervisory regulation and inspection. Every country in the world has local supervisors, like I know there are a lot of people from Australia attending. In Australia, it's the ARPA, Australian Regulation and Prudential Authority. In UK, it's the Bank of England. And all these supervisory authorities will closely inspect the analytical models that are built for credit risk modeling. They want to know what makes a customer go into default, yes or no. And with neural networks, that is very hard to say because they're very complex mathematical techniques. Operational efficiency is another criterion. We are currently working with a credit card company in Europe to build fraud detection models there. And we developed various solutions based upon neural networks and based upon social network analytics. But there, a key requirement is operational efficiency. We only have a time window of 6 seconds to decide whether a credit card transaction is fraud, yes or no. So we should be capable within 6 seconds to make the decision, fraud, yes or no. This puts a huge challenge on our analytical models. Obviously, we should also take into account the economical cost. What is the cost to gather the model inputs, to analyze them, and run our analytical model? And last but not least, there's the regulatory compliance issue. To what extent do our models respect the regulation? To what extent do we respect privacy guidelines, etc.? The point I want to make with this slide is that there's more to analytic model requirements than just statistical evaluation or performance. And it all depends upon the business setting you're working in. Marketing, fraud, credit risk, online, etc. Post-processing means that you're going to deploy the analytical models into a business setting. You're going to integrate them with your capital calculation engines, with your fraud detection system, with your marketing campaigns, and so on. And the first step you're going to do here is interpret and validate the analytical models by the business expert. The business expert, and many of you are business experts, I'm sure of that, will look at the analytical models and start interpreting and validating them to see whether they make sense and to see whether they add value to their specific business problem. This can then be complemented with some sensitivity analysis to see how sensitive the analytical models are with respect to the internal environment and the external environment. In terms of external environment, think about the macroeconomy, for example. You can then deploy the analytical models into the business setting and start building monitoring and backtesting frameworks. Because what's the average lifespan of an analytical model? Well, it depends upon the setting, but in many settings you will see that analytical models will not run longer for, let's say, 2 or 3 years. I would like to now zoom into some new applications that we've been working on. And the first one is social network analytics. And when I say social network analytics, I am not referring to Facebook, Twitter, or LinkedIn. Obviously, these are very popular examples of social networks, but to me, a social network can be any network of nodes connected in a particular way. Think about a telco provider. Imagine that you're Vodafone or AT&T or any other telco provider, and the nodes represent your customers. And the edges represent people calling each other, right? The edges represent people calling each other. This is a network that you can build upon CDR data, call detail records. Every time a person makes a call, information about the call is stored into a huge log file, which can then be used to construct a network. That will then allow us to do churn prediction and to see if I have one influential node in a network who will leave AT&T or Vodafone, are there any of the neighboring nodes, any of the friends who are likely to leave? We found some significant social network effects when working with two major telco providers in Europe. It can also be used for fraud detection, where we have companies which are linked to each other by means of the resources that they share. When I say resources, I'm referring to employees, I'm referring to equipment they share, etc. Social networks are very important in analytics. I'm going to show you an example of a telco setting. In this short movie, I will build a network based upon real life data that we gathered from a European telco provider. So you can see the blue nodes represent customers, right? The blue nodes represent customers. I just click the pause button and you can see a churner right here. The red one is a churner. And let's now see what is going to happen in the network chronologically, how it's going to evolve. So you see more churners, you see more churners, more churners. These are all snapshots in time, how the churn behavior spreads in the network. More churners, more churners. All of a sudden, you see churners next to one another. The closer they are situated to one another, the more frequently they exchange calls with one another, right? So you can see neighboring nodes that start to churn, which indicates the presence of social network effects, right? You can see it more closer, and you can see a whole chain. You can see this chain right here. There are three churners close to one another. Those are three friends, people who frequently exchange calls with one another. So somebody initiated the churn behavior, and it directly propagated to his or her neighbors. You can see a bigger chain, right? This is a chain, a social network chain. One of them got dissatisfied with the telco provider, and by churning, he or she also took along some of his or her friends. Obviously, we want to prevent that, and that's something you can detect using social network analytics. We have seen those phenomena not only in churn, but also in fraud detection. So what we do right here is social fraud detection. We look at networks of nodes. The nodes are companies, right? And the links are shared resources. And resources, you can think of resources like employees, as I mentioned. You can think of them as shared equipment, etc. We have found some very strong effects there because fraud is a very social phenomenon. You see many fraudsters that are basically going to set up fraud rings or collusion practice. That means that they collaborate together with malicious intent. We have achieved some really amazing lift values by incorporating social network effects into fraud detection models in insurance, in credit card, and social security or tax evasion fraud. Right? What we basically do there in social networks for fraud detection is we look at the fraudsters in the network and we see how they are going to influence their neighbors. How a fraudster will contaminate his or her neighbors with fraudulent behavior. And that's a very strong effect that we have seen. To do this, we have made use of all kinds of fraud propagation algorithms. And one of the newer contributions that we have developed in this area is the use of the Google PageRank. Google PageRank is an algorithm which you can not only use to rank web pages based upon their relevance in Google, but you can also use it to see how fraud is spread from one company company or from one node to another node in a particular social network. Here you can see basically the approach that we have developed. We call it Gotcha. It's a fraud detection system that we have developed, which uses all kinds of data. I'm not going to zoom into the architecture. I'm just going to highlight a few things. Basically, what we do in our Gotcha framework is we make use of local attributes. These are node-specific attributes, attributes that we have been using previously in analytics. Local customer information like a customer's age, maybe even a customer's RFM characteristics. And those local attributes, we're going to complement them with direct network attributes and indirect network attributes. Direct and indirect network attributes which we have extracted from the social network that we have constructed. And by doing so, we can significantly boost the performance of our analytical fraud models. We then merge both into a baseline and network data set and then use a learning algorithm like logistic regression or random forest to build our social network learner. Here you can see some of the lists. I'm not going to zoom into them. I just want to highlight something that really struck us in credit card fraud detection. By including social network effects into the model, we could reach AUC values. AUC stands for area under the ROC curve. It's a number between 0 and 100 for those of you that are not familiar with it. And the closer it gets to 100, the better the performance of the model. For many analytical models, it ranges between 80 to 85. In credit card fraud detection, we got it up to 95, even sometimes 98, by including network effects. And that was really amazing to us. And this is not just one study, because we validated our study in different settings in the meantime. So the point I want to make here, social networks are hot, are important. Briefly, I will go into process analytics. This is another totally different application area that we're working on. I haven't seen many successful business applications of it yet because it's still very academic in nature, I have to admit, but I do anticipate lots of successful applications in the next 5 years. The idea of process analytics is the following. You start from an event log of an information system, as you can see to the left. The event log records a case idea, the activity like make order form, scan invoice, an originator, a timestamp, and any other case or extra data. Based upon this event log, which you can extract from an information system, you can actually also think of a web log, we're then going to mine the process model using a process mining technique. And there exists some process mining techniques like genetic miner, heuristics miner, one which we have developed within my group, which is Agnes Miner. Those will then come up with an analytical process model. They will tell you the various steps of the process as they have been recorded in the event log. That will actually allow you to see what's going on in your business, what's actually going on in your business process model. Can we optimize this process model? Is this process model okay from a regulatory perspective? Think about regulatory compliance and so on. So that will allow you to better understand, optimize, and streamline your key business process models. Very exciting area. At this moment, it's still a bit theoretical, but I expect lots of business applications in the next 5 years. Finally, an area which I have been working on lately as well is applying analytics in a human resource setting to predict employee churn, to predict employee performance, to predict employee absenteeism, and so on. And many of the ideas that we have developed in credit risk analytics, marketing analytics, or fraud analytics can be directly transferred to HR analytics because from an analytical perspective, whether you're analyzing employee churn or customer churn, basically the idea is just the same. It's just the data that is different. So we have collaborated with some firms to build absenteeism scorecards and so on. So to the right, you can see an example of a scorecard like that, whereby you look at all kinds of characteristics of the employee like age, function, department, and to each of those categories you assign points. The higher the points, the better the quality of, or the more likely the customer or the employee in this particular case is going to be absent. This will then allow you to score all your current employees, your current workforce, and see which employees or more likely to be absent than others and take appropriate actions from an HR perspective. Okay, so this finishes my very short webinar. We set the stage, we looked at various types of data, we zoomed into the analytics process model, we zoomed into the analytical model requirements, think about business relevance, think about statistical accuracy, interpretability, operational efficiency, economical cost. We zoomed into some newer application areas, social networks, business process, HR analytics. Before we finish and before I allow you to do some questions, because I'm sure there are some questions, I would like to give you some further pointers to background information. I need 5 more minutes and then I will take all your questions. I have enough time to answer any questions you have, so make sure you can already start thinking about questions here. First of all, you can find some background information right here. These are some background publications, and I've also included a link to my website, dataminingapps.com, where you will find lots of material for free. That means short overviews of the domain, background publications, even short movies if you would be interested. Here you can see actually the screenshot of my dataminingapps.com. I've published various books on the topic. To the left you can see my credit risk management book. My most popular book at the moment is the book in the middle, Analytics in a Big Data World. We have been translating this, we have been selling this to more than 3,000 customers worldwide. You can find it on Amazon. If you just Google my name or the title on Amazon, you find Analytics in a Big Data World. Remember, I told you that programming is also very important for any data scientist. That's why I recently wrote a book on Java programming as well. And the good news is it's available for purchase since yesterday. It came out yesterday on Amazon. We are currently working on a book on fraud analytics. And we're finishing this in the next 2 weeks, and it will be available in the next 4 to 6 months. I teach various courses on the topic as well. Some of them are very application focused, like I have a credit risk modeling course. This focuses on how to develop PD, LGD, and EAD models, how to validate them, or how to stress test them. The course is organized in collaboration with SAS, but it does not focus on the SAS software at all. It focuses on the conceptual modeling. So actually, on average, about half of my participants do not use SAS, but use R, MATLAB, etc. I have a one-day course, Analytics Putting It All to Work, which is just the overview course. I have an advanced analytics course in a big data world as well, which goes more into neural networks, into social networks, support vector machines, survival analysis. We have a web analytics and web intelligence course, and we have a fraud analytics course. Our fraud analytics course is our most recent analytics course where we discuss supervised, unsupervised, and social network learning techniques. All of these courses, despite the fact that they're offered with SAS, focus on the general concepts of building the analytical models. And then we also give very brief demos or exercises of how you can use SAS. But even if you would use other software, then that is fine. Also important to note is that we have been teaching those courses in Australia, in the UK, in the US, all over the world. But recently, we started to develop e-learning versions of those courses, especially of the first one, credit risk modeling, and of the third one, advanced analytics. And let me briefly tell you something about that before I take your questions. My credit risk modeling course is available as e-learning. You go to this website here. My advanced analytics in a big data world course, I'm currently turning it into e-learning. It will be available as e-learning from April the 15th onwards, so that's in about a month from now. The idea of those e-learning courses is that it's self-paced e-learning, so it's about 22 hours of videos, demos, scripts, and quizzes. I'm going to show you a demo in a moment. So it means you can take the course whenever you want, and you can watch all those videos during 1 year. Once you have registered for the course, you get access to all materials during 1 year. You can watch the videos whenever you want, you can play them back as many and whenever you want, and so on. The e-learning courses focus on the modeling concepts and the methodology. Despite the fact they're being offered with SAS, there's no SAS software you need. There's only a laptop you need, an iPad, iPhone with a web browser. You will also get a certificate upon completion of the course. I'm just going to show you a brief demo. I included some slides, but I prefer giving you a live demo of my SAS course. So I will just go to SAS, to the website of SAS, where you can register for the course. Right. And then I go to support and training. Right, support and training. Here I go to training. And then I go to my training. And then I can see all the e-learning courses where I am subscribed to. I go to my training. And here you can see the credit risk modeling course that I've been talking about. So this is the start screen. I can then click start course. And then you can see the overview of the course, right? I'm not going to go into it. I'm just going to give me 2 more minutes and then we can wrap up. So here you can see all the lessons. The course has been subdivided into lessons: introduction, Basel Capital Accords, preparing the data for credit scoring, classification techniques, logistic regression, and so on. In this course, we go into PD, LGD, EAD modeling, and so on. So let me just click one of them open. So let's go to logistic regression, for example. That's a very popular analytical technique. It's the most popular analytical technique. So this is a movie. The movie takes about 8 minutes, and it shows you the basic concepts of logistic regression. Every movie is also subtitled, right? So I'll just play it. So these are just all kinds of movies, and the course also comes with quizzes. So every now and then you're going to have a quiz to see whether you understood it, yes or no. And then every lesson also ends with a general lesson-based quiz. Demos are also included in base SAS and SAS Enterprise Miner. They're also as movies. So upon registration, you can actually get 1 year access to this application. You will receive a code, 1 year of access, and you can play the movies as many times as you want. So as said, we have the course available right now for credit risk. It's already available for purchase for credit risk analytics. We are still working on it for advanced analytics. If you would like to have more information, or if you want to be on my notification list for advanced analytics, just drop me an email. Okay, so would like to thank you for your attention. I guess I'm ready to take your questions right now.
Thank you, Bart. We've got a question here from Omar. What are the questions as a manager I can ask to validate the data and make sure that output presented to me by someone has gone through the right data steps and there is no error in sampling and evaluation?
Okay, that's a very good question. Thank you very much, Omar. Your data is never going to be of perfect quality. If you would like to wait until the data is of perfect quality, you're never going to get anything done. But the good news is that the data should not be of perfect quality in order to build meaningful analytical models. But in terms of data quality efforts that should have been undertaken, you should actually consider all the data dimensions that I have covered previously in my talk. You should ask your data scientists, your data modelers, to what extent they have been diagnosing data accuracy problems. Have they been diagnosing data accuracy problems? And more importantly, how have they been remedying data accuracy problems? Now, data quality is something that you can remedy in the short term using appropriate statistical procedures, but in the long term, you need to carefully think about how you're going to redesign your data entry processes by including integrity constraints, validation constraints, etc. But data accuracy is only one part of the picture. So besides asking all this information for data accuracy, you should also ask it for data completeness, data recency, and so on. So you can use all those criteria that I've outlined before and ask your modelers to what extent they have addressed those and to what extent they have diagnosed any issues in all those areas. Thank you.
Another question for you here, Bart. Can you give an example of how social network effects can be integrated into a predictive analytics model?
Now that's a very good question. I think that's a very relevant question to anyone attending this webinar who might potentially think to include social network effects into their predictive models. And I'm going to give you a very straight answer to that. what are the most commonly used predictive analytical models in the industry nowadays? If you would ask me, Bart, rank your top 3. What are the most widely used predictive analytical models used in the industry? I would say rank number 1 is logistic regression. Rank number 2 is decision trees. Rank number 3 is random forest. One way to include social network effects into all these 3 models is by doing featureization. Featureization means that you build your social network, and based upon the characteristics of the social networks, you come up with features. An example feature could be, how many churners are connected to Bart? Is Bart connected to a churner, yes or no? These are examples of features that you can very easily add to your data set and then analyze the data set again using logistic regression, using decision trees, using random forest. In that way, you're actually incorporating social network effects into your predictive analytics models to boost their performance. That's the most important way. Thank you.
I think we've got time for one last question. What are your thoughts on the value of data analytics for health and safety, given the large sample sizes and millions of hours worked and low frequency of events?
Low frequency of events, that's a very good question. Thank you. It's a very specific one. A low frequency of event is something that we do not only find in health and safety, but we also find it in churn, because on average, about only 1% of the people churn. It's even worse when you look at it in fraud detection, because in fraud detection, the number of fraudsters are very low, usually less than 1%. So very skewed or rare events is something that occurs across a diversity of different settings. There exist mechanisms to deal with that in an analytical perspective. Those mechanisms are always targeted towards increasing the importance of the rare events, and you can increase the performance of the rare events using very specific sampling procedures, like undersampling, oversampling, or for those of you that are a little bit more technical oriented, there's a very interesting sampling procedure which is called SMOTE, S-M-O-T-E, which we have recently studied in a fraud detection setting, and which actually allows to rare events, as you can also encounter them in health and safety settings. So increasing the importance of the rare events through any of those sampling procedures is something that is very important if you want to appropriately model them.
Fantastic.
I hope that answers the question. Thank you.
Thank you very much, Bart. There's been a few requests for you to pop up the e-learning link. If you could maybe just do that on your slide for me, Bart, that'd be fantastic.
Yeah.
Thank you for your presentation. It was very interesting. To view our upcoming events, jobs, career advice, and insightful blogs, please visit www.morganmckinley.com or follow us on LinkedIn or Twitter @MorganMcKinley using #SuccessSeries and #CareerAlly. We look forward to receiving your feedback and hope you have a pleasant evening.